For evaluation, there are a lot of pitfalls that comes when it comes to evaluations, like, asking model to grade the thing directly, because models are very stochastic and grading it directly would rather trigger them to give some random number, which is more probable than anything related to the given question and answer. So when it comes to evaluation, how we use models as evaluators is by subsetting the task itself into multiple principles in their task, and then using these subset outputs to come with an answer, which come with a number, which is also very quantifiable in a manner.
Hey buddy, welcome back to another episode of How AI is Built. Today we have two very special guests. Shahul and Jithin are building Ragas. Ragas is the open source library to evaluate, adapt, and reliably build RAG applications that are ready for real-world deployment.
January of 2023, both of us actually quit our job to explore more on the LLM space, because like 3.5 was a mark at what the capabilities of the models were becoming. So we were trying to figure out what all applications that is possible. So we were like, Shahul was working on the Open Assistant project, which was trying to create an open source ChatGPT. I was contributing to Llama Index and LangChain, and both of us were helping a bunch of clients to help them get these things into prod. And we quickly realized that a good demo doesn't take a long time, but then making sure it's actually production ready, it's actually good for deploying to their users, is like a long journey, and the tools were not there to build it. So because both of us were coming from an ML background, we knew how the ML way, like the old way of doing this, which is like we have like a test data set which covers the different distributions that your users might have, like actual product might see in like production, and that we have a validation set, and then we keep iterating those parts. So that is an approach that we were familiar with, but there was nothing like that here. But when at the end of the day, when you look at this, these foundation models are still ML models, right? So we figured that lens to viewing this evaluation problem and testing problem is very important, and that is why we started like Ragas and this open source tool. So initially it was just a small like project and like a few other metrics, and then we have been slowly iterating it over and over.
Yeah. Shao, maybe on the open assistant part, like what were the biggest challenges you've seen, like more on the LLM side, that actually is the stuff you really want to like tackle and bring into building Ragas?
Yeah, the Open Assistant project actually gave me a lot of exposure to training large language models. I mean, till then I've been in the language model training from 2018, but now it was a step change, as Jithin mentioned. And the goal of Open Assistant is something which really attracted a lot of people and also attracted me, that they wanted to create an open alternative to ChatGPT by 2023. If you remember that period, we started around 2023 early Jan. Now, none of these foundational models which was released was there back then. The only foundational models was, Pythia, all these old foundation models, which were like 10, 15 billion parameters maximum. And this was pre-Llama era, to be specific. So it was very challenging to find a good foundation model. And then we had to innovate on all the techniques that OpenAI was using, basically their Instruct GPT paper on fine-tuning and aligning large language models. And now we have a lot of frameworks to do all these stuff. Back at that time, we were basically writing the whole, structure code and everything for this ourselves, experimenting with different combinations of that. And from that, the biggest learning I had is about open source large language models and how we can align and modify, post-train these models to be of a great use on any particular applications rather than just going for closed source models. The thing about open source models is that it does not come out of the box to be very useful. But if you are able to spend time in the post-training process, you could benefit from it. So that's something that we are also taking to Ragas when we are developing models for our applications in Ragas.
And in general, when you're looking at the ways you can adapt a model to the use case of the end user, what parts do you see like going to the continued pre-training or fine-tuning, and what parts belong to RAG? So how would you separate these two?
So when talking about adapting foundational models to applications, the techniques we adopt is actually dependent on what we are also trying to achieve. So if we are basically trying to achieve some level of alignment with the model by just in terms of style, in terms of output quality and all these stuff, some post-training methods like fine-tuning or DPO or even RLHF can work. But if we are trying to fundamentally modify the model's knowledge to add new tokens and add new domain or world understanding, we would rather go for some continuous pre-training. In Ragas, we actually focus on post-training methods such as fine-tuning and alignment. We were just training this smaller model for synthetic data generation. There is an application in Ragas where we generate synthetic test data sets, and these are very, very costly. So we are running some experiments on smaller models in post-training process to distill these capabilities to smaller models so that people can use it on a cheaper and faster rate.
Yeah. And looking at Ragas, what would you say are like the main components from a user's perspective? So when a developer jumps into the project, jumps into the documentation, what are the main steps he has to go through to basically get Ragas working on his LLM and his use case?
So Ragas, a typical user of Ragas will be someone who has already built the RAG, mostly in some startup or enterprise, and is looking to either evaluate and test the quality of their RAG before putting it into production. So that, this is a typical user of a Ragas, and how we can use Ragas is Ragas actually provides two components. First thing is metrics, which provides in-depth objective quantification of how different components of your RAG pipeline are performing, such as retriever, the generation part, query transformation, reranker, etc., etc. Another thing is synthetic test data generation. So whenever a developer wants to test or evaluate his application, the first issue he will face is the lack of a proper test data set. So what we figured out is we could synthetically generate this test data set. So the idea here is to reduce the developer time in acquiring these test data set by 90%. Now the developer's job is to just go through the synthetically generated data set, filter some of the data points that he doesn't really like, and then he'll have a proper test data set rather than replacing the whole process. So these are the two components that developer can use. To start off Ragas, you could just go through our beginner starter notebook. It is a simple notebook that anyone can run. We also have provided a simple example data set for Ragas. Usually you can replace it by your own data set after trying out first. But for the first run, just a quick start notebook in a simple, run all matter should work. He should get some numbers at the end. Then you could, of course, go and explore Ragas.
Yeah, and from the user flow, because you mentioned the different components of like your RAG system are evaluated, is that after your synthetic data was created, or do you already have some components which can evaluate the different components without the synthetic data set?
Yeah, so the first step in evaluating or testing is data creation. Either it is synthetic or manual. So if the user already has a manually annotated data set, he could use it. If he does not have that, he could use synthetic data generation to generate the synthetic data. The synthetic data will contain a set of questions and expected ground truth answers. The developer can then just feed in these questions to his RAG pipeline, get required information from RAG pipeline, like the generated answer from the RAG, the retrieved components by the RAG, retrieved chunks by the RAG, etc. And then he will have a data set containing 3-4 attributes, including all these. And this can be used to get any metrics, to run any metrics out of Ragas. For example, faithfulness is a metric Ragas provides, which basically measures the hallucination of the generated answer given a ground truth context. So for this metric, you would need question, the retrieved context, and the generated answer. And Ragas with faithfulness metrics will give you a number between 0 and 1, quantifying the hallucination associated with each generated answer given the ground truth context.
Great. And especially looking a little bit under the hood, you already mentioned you trained a model for creating the synthetic data set, but what is the input to that model? Are you already using a few examples from the user system?
We do not really collect any user data. All the data that we use to train models are synthetically generated. We do a ad hoc data preparation process. So I'll tell you the problem on why we are trying to do this at the first step, because now the synthetic data generation process is slightly complicated. It contains two types of LLMs actually. We use two types of LLMs, or LLMs as two different components. The task of one LLM is to generate, just to do all the generation. For example, generate questions, generate answers to these questions, all these stuff. Another LLM is called critique LLM. The task of critique LLM is to give feedback to these generations. For example, if the generator LLM generates a question, the critique LLM will come and critique these questions. And every question generated by LLM will not be of high quality, right? So job of critique LLM is to be a critique and give feedback to these generated questions and to improve the quality of these questions. That is a brief overview of how the whole synthetic data generation algorithm works. So the problem that we were facing is that we were using GPT-4 as a critique LLM. Of course, user can use any open source models. Ragas actually supports almost any open source model supported by LangChain. But we were by default using GPT-4 because we saw that GPT-4 is very effective as this critique. The problem of using GPT-4 is that it is more than 10, 20x expensive than any other model out there. And people were limited by the cost factor of this. So what we are trying to do is we are trying to abstract the task of this critique LLM to a smaller LLM. So that the job done by smaller LLM would be just to give feedbacks to the questions generated. Maybe, there are some feedbacks also the critique LLM should give. So this part is done by the critique LLM, which we are abstracting to a smaller 6 billion model. And we are also open sourcing it. And it will be ready in 1 or 2 weeks. We only have an MVP by now. But the idea here is to reduce cost of generation so that people can generate more data points. If someone is doing 100 data points today, he could do 1,000 data points at the same cost with our smaller model.
Yeah. And when I'm thinking about synthetic data, I'm thinking about the distribution I'm trying to model. How do you actually try to model a distribution within text data with the user inputs, but also the actual outputs of the model?
So we actually saw some of other works in text data generation and were very dissatisfied with this particular aspect of it because of the lack of distribution, the diversity in the question generator. So we actually came up with algorithm which uses LLMs, but there are several steps in which the questions generated itself are, evolved to different question types. For example, in terms of RAG, it could generate questions that are, very simple and straightforward to answer. And that can be a particular category of question. Then there are questions that requires multiple documents to answer. So this is another category of question. And then there are questions that can be only answered by advanced reasoning. And we simulate all these questions using an evolutionary method. Okay, we'll generate a simple question. We might evolve that question into a question that requires more reasoning to answer all these steps. So there are some parts of the algorithm that facilitates this. And we actually came up with this algorithm inspired by some research. We're also going to write a paper on that too, which is kind of pending. But yeah, we try to ensure maximum diversity in it. We want to ensure more diversity in it. Going forward, what we are trying to do is we'll connect our infrastructure to the production data so that LLMs can get inspired from the distribution of production data and then generate questions that are actually very similar to that of production data, which can be very valuable when it comes to forming an evaluation of test data.
Yeah, I've seen, especially in creating fine-tuning data sets as well, I think one of the biggest issues is actually that mostly the inputs that people create do not really reflect the actual inputs that the user will put in.
Yeah.
Nice. Jumping to Jithin, do you have a really interesting use case story of what you have built or what you have seen from one of your users of how Ragas is used in production or in a trial right now?
I have one interesting use case where the engineers in Melvess, they were doing a grid search on the different components of the RAG pipeline. And if you want to do grid search, you want some sort of evaluation to back it up, right? So they were searching through different areas of improvement, what are the embeddings that you can use, what are the different chunking strategies that they can use. And they did a grid search there. And then because they had a good score to figure out good score to objectively measure it, they were able to search a wider space. So that was a good interesting thing. And personally, I'm also excited about how you can combine the DSP model compiling step and Ragas methodology. That's something we have to explore, but that is something that we're working. That would be really cool to see.
Yeah, one really interesting use case in a similar vein I've seen from LanceDB, where they are working with one AutoML provider, and basically they're embedding the different models and searching them for optimization by looking at the typical data set you get from the user.
Yeah, especially like once you have like good ways to measure stuff, then all these like doing optimizations automatically becomes like possible. And that's like a future that we want to take. But then, yeah, let's see where it goes.
And looking at the use cases again, what are like the characteristics of the use case of the application where you say like Ragas really fits to solving that problem or fits within that use case?
So I think that will be the use case that we just started off with, which is that you are a developer, you want to build something in your company and you want to get it into production, but then you want to test it thoroughly before you release it. So there, and you're building a RAG pipeline because that is what we currently focus on. You can like use the Ragas metrics, you can optimize the different areas for if you want to improve the recall of the retriever, if you want to improve the precision of the retriever, if you want to like detect which LLM you want. All the step becomes like systematic way of slowly measuring and improving, and that's the start thing we started off with. Now we are, that's the thing, that's the most powerful use case even today.
Yeah. And I think when I'm looking at like the evaluation space so far, what I mostly see is like some evaluation stuff from the bigger provider like ML Flows, Arise. You're raising around right now. Can you maybe like teaser like where Ragas will be moving like as a product and as a company beyond the open source product?
So like Shahul mentioned, right, all the innovations that we are doing on one stack below, which is actually tackling the problem of what does it actually mean for a model to do the evaluation when the original source of truth is a human evaluator. And what you're seeing is that that gap between model guided evaluation and human guided evaluation is getting smaller and smaller. And there is like more important things like synthetic data generation that Shahul mentioned. All these like augment the user, like augment the developer to reduce the grunt work that is there in testing it. And if you reduce the grunt work, that means you're working on more interesting problem. The iteration, like how fast you can iterate on your problem, like your product increases, and that means you can build even more ambitious projects. And that's the future that we want to support.
What is your vision, maybe how Ragas intersects with like the data-driven AI movement, where you actually try to basically make AI really automated by only looking or mostly looking at the data, and you look at basically the error rates in different categories and in different areas of the data, and then label additional examples, and then basically do a new training run until the model finally hits the threshold where it's good enough.
Yeah, I mean, but other than the data route, what is the alternate route?
What is alternating? So basically, you're only iterating on the data. That's what like data-driven AI is mostly about. You're looking at your data set, you're looking at the mislabeled examples, you're trying to figure out like what is the issue or where does it arise from, and then you label additional examples, which are basically like the counterweights for the model for that specific error.
Yeah, so okay there, but then what I was trying to figure out is like what is the other way, like other way you could do it.
I think nobody changes architecture these days because changing the architecture is the next way, and changing architecture is too risky. I think even players like OpenAI doesn't change the architecture that much. They change the model's nature a bit. For example, they might do something like we have something like the idea of sparse models. But the idea of sparse models in transformers, if you see the architecture itself, it's exactly the same, just that they have more routers in it. So there are basically two methods to improve the performance. One thing is changing the architecture, another thing is having better data and scaling the model, of course. And it seems like what we are currently focusing on as a domain is having better data. If you see some of the recent models that were released by O1, their entire architecture is very similar to Llama 2, but what they extensively focused on is having a very good data pre-processing pipeline so that they feed the best data, only the best data to the model, and they feed it to the post-changelog amount. And this is what they have done to achieve similar performance similar to Llama 70 billion by just a 34 billion parameter model. So I think we have a lot to learn about what data to be input to the training so that we get maximum results out of it. And that optimization seems to be something which is like still people are trying to figure it out and all this stuff. Like my idea is that if we do not really know what LLM really understands, so a data which that we cleans or even post process to be as perceived as clean might not be optimal for the LLM. LLM might have a different type of optimal data processing thing that it better understands. So as we are running more experiments on the data, I think we'll find more about the best data preprocessing methods that we can use to get better performance out of LLMs.
And extending that to the RAG use case, because what I've often seen and also read about is actually that one issue is that the user input and the documents which are in the vector database aren't basically in the same latent space, or they're too distant from each other. And there are like a bunch of techniques already, like HIDE, so hypothetical document embedding, which basically tries to mirror the documents through the user query by using an LLM as a step in between. Have you seen like any other like interesting or uncommon pre-processing steps for RAG on the data which really seem to work well?
There are several methods that have been proposed. One is HIDE, as you mentioned, but there are methods that even align the LLM and the embedder. So one of the core assumption is the used LLM embedding model are not very much aligned to each other. So there are methods by which, is the embedding model actually retrieving contents that the LLM would actually prefer to see or not prefer? And there are methods that are proposed to align the embedder and the LLM model. These are two different components and different two models, right? And if there is an alignment between these two models, you'll get better performance out of RAG. So there are even advanced, methods that has been proposed to just so that you could align these both and get better performance out of RAG. And there are all these intermediate methods or techniques that you can use to get better chunking mechanism. For example, fine-tuning retriever, or using a reranker, or doing some kind of query transformation. People even transform the single query into multiple queries and then do retrieval on multiple queries and then do the reranker on top of it. So there are all these techniques out of it, and there are methods that are also even continuously evolves and aligns the LLM and embedder so that it basically learns by itself and over time and retrieves better chunks. So yeah, RAG is kind of getting more complex, but I think as the methods evolve, some of the core methods will survive, and that methods is mostly going to be used after that.
Yeah, and in the paper you already have like extended and detailed a bunch of different metrics you're using to evaluate the context, which is basically fed into the model, and then also the answer. I think at the moment most people are actually like over focusing on the answer part and not really evaluating the context. Can you maybe go into like a few of the metrics you have implemented in Ragas and quickly describe like what each one captures and where or for what use cases this metric is especially relevant?
When it comes to metrics in Ragas, we actually have two types of matrices. One is end-to-end matrices, which actually quantifies the performance of the pipeline in an end-to-end manner. So the goal here is to compare the generated answer with the expected answer. So you can do different types of comparison. You could do different types of quantification, but this will only give you the idea of how the pipeline performed in an overall manner. Then there are matrices that are isolated towards components. For example, retriever. The matrices which we use for retriever is matrices that are like context precision and context recall. Basically, these are traditional IR matrices which we have evolved for the Gen AI applications. And what these two matrices capture is how efficient your retriever is performing, which is very important when it comes to RAG, because if the retriever mess up, there is no possibility that the RAG will give correct answer. And there are similar matrices for the generator part too. So the generator part, we have matrices like answer relevancy, the faithfulness, and people were actually proposing new matrices on that part, like, to quantify the diversity and all that stuff in the answer. So we might have more matrices going forward, but the goal is to provide the developer with an easy idea on how to use these matrices and navigate through these two matrices, because software developers are not much used with the idea of matrices, a lot of formulas, a lot of iterations and all this stuff. But going forward, we'll have an easy to interact method by which, or documentation, it should be solved by a documentation by which software developers can easily navigate through the space of matrices and methods and understand and use this very efficiently and easily.
Yeah. And beyond like the different quality metrics of the context and the answer, like are there additional like group of metrics or metrics you would monitor for a RAG application?
Yeah, going forward, these are like mostly offline matrices. Going to an online situation, we can have many other matrices. For example, it really depends upon the application a little bit, but we could have models and matrices that actually quantifies the quality of the conversation itself. But RAG in these days is not a single short question answer, but rather a conversation. User might ask one question, then ask a follow-up question, then it's a conversation. So we could have a matrix that can quantify the quality of conversation by using implicit signals. Like, for example, if the user asks the same question 2 times, that means that there is a problem in that particular answer or that particular conversation. So going forward, we'll have such matrices to ensure the quality in the or live phase of production as well. But that's in the future.
And in my opinion, like mostly AI and also data, it's a game of knowledge. It's like so many different hacks, tricks, and optimizations you can do, and you only figure it out by really being deep in the space and trying a lot of different things. What are like the little hacks and tricks you have seen working in RAG and also RAG evaluation?
In terms of RAGs, I think there are a lot of hacks and tricks these days, including, all crazy query transformations or different types of getting the answer out of models. So for example, chain of thoughts is one, widely used, and then there are different varieties of chain of thoughts itself. So I would rather go for something that is robust rather than very or fitted to the particular snapshot of LLM. That is something which I prefer in most cases. I prefer robustness over optimization, especially because of the nature of closed source LLMs, and most of the industry is just using closed source LLMs as of now, in which they do not really have control over ways. Even with open source LLMs, if a data scientist or ML guy is working on it, he usually updates and works on the models and improve it. And there is not really control over models, prompts, or the exact output rather. So something which is robust is something that I really prefer, and something that really works is reranking, query transformation, as you would know, and of course parsing and storing chunks in the best way as possible. So that's it there. For evaluation, there are a lot of pitfalls that comes when it comes to evaluations, like asking model to grade the thing directly, because models are very stochastic, and grading it directly would rather trigger them to give some random number which is more probable than anything related to the given question and answer. So when it comes to evaluation, how we use models as evaluators is by subsetting the task itself into multiple principles in their task, and then using these subset outputs to come with an answer, which come with a number, which is also very quantifiable in a manner.
Yeah. And maybe putting you even more on the spot right now, especially like Jithin, as well as you have been working with a lot of partners. Looking at the greater ecosystem for RAG, you have like a bunch of components you have to put together. You need like an embedding model, a vector database, you need an evaluation system. What is your dream tech stack for RAG together with the Ragas?
Yeah, we don't have a dream tech stack. That will be like too much opinion, because like we love all our partners. And the thing is, the goal of Ragas is to figure out the dream tech stack for our users, figure out what works well for them. So yeah, we don't have any strong opinions. Whatever is like the best, like we provide you the tools to test it. The user makes the call. We don't have a call there.
Okay, nice. And then what's something you're missing from the space, from RAGs or from the LLM space at large? What is something you would love to see build beyond RAG evaluation, what you're building right now?
One thing like that, like I'm particularly excited about, is like all the things that we are doing on the production monitoring phase and expanding the metrics. So when we are talking to like a bunch of customers right now, okay, RAG evaluation is there, but we have to expand more horizontally to cover all the other ways. Like people are building much more different LLM applications, and like figuring out how to actually evaluate that, and also how to evaluate that in production, how to use all the implicit signals and explicit signals coming from production, how to leverage that. All that is like challenging things that are there, and also like pretty exciting because interesting problems to solve.
Yeah. And what's next for Ragas? What you can teaser about your roadmap? What are you working on right now?
Yeah, so Shahul, as he said, like the synthetic data generation piece is the thing that we are doubling down on. So that has been promising. So we'll release some open source models there, and releasing that is always exciting. So yeah, that's the next things. Shahul, you want to add something?
No, I think as a framework, that will be the next release. And of course, we will have features and more matrices that cover different applications. Inside RAG itself, there are different applications people are building. So we have to have extended support to that too. And you could expect all those in the next stable version.
And where can people follow along with Ragas and also get in touch with you?
Yeah, so the best place is like our Discord community. We regularly put updates on like what is happening. Moving forward, we are going to make that more there. But all our socials like LinkedIn, Twitter, all that also works.